Manganese heptoxide. Just the name sounds intense, right? And for good reason. This stuff is not for the faint of heart. We're talking about a chemical compound with the formula M2O7. It's a dark green, oily liquid at room temperature, but don't let that fool you. This stuff is ready to react, and when it does, it's a sight to behold. Manganese heptoxide is known for its instability. It decomposes easily. Even at temperatures just above room temperature, this decomposition can release heat, oxygen gas, and even ozone. Talk about a recipe for excitement. But what makes manganese heptoxide truly remarkable is its oxidizing power. This compound is like the ultimate electron thief, eager to snatch electrons from other substances. And when that happens, things can get explosive. So if you're ready for a wild ride through the world of chemistry, buckle up. We're about to dive into the fascinating and sometimes dangerous world of manganese heptoxide. Now, you might be wondering, how do you even make something as volatile as manganese heptoxide? Well, it's a delicate process that involves combining two very different chemicals, concentrated sulfuric acid and potassium permanganate. You know sulfuric acid, the stuff that can eat through metal? We carefully mix that with potassium permanganate, a common oxidizing agent. The sulfuric acid acts as a dehydrating agent, pulling water molecules out of the potassium permanganate. What's left behind? That's right, our friend manganese heptoxide. But here's the catch. You have to keep the temperature low. Remember how we talked about manganese heptoxide being unstable? Well, heat it up too much during the reaction and it'll start decomposing before you can say chemical reaction. So creating manganese heptoxide is all about balance, the right chemicals, the right proportions, and the right temperature. It's a delicate dance, but when done correctly, it yields a substance with incredible reactive potential. Now for the fun part. What happens when manganese heptoxide reacts with other substances? Get ready for some fireworks. Remember, this compound is a powerful oxidizer, so it's always looking to steal electrons. Let's start with something simple, like cotton. Touch a bit of manganese heptoxide to a piece of cotton and watch what happens. The cotton bursts into flames with a bright flash. That's the power of oxidation, but it's not just cotton. Manganese heptoxide reacts explosively with a range of organic compounds. Ethanol, boom! Acetone, bang! It even reacts with things you might not expect, like potato chips, although not as violently. These reactions happen because the manganese heptoxide is so eager to gain electrons. It rips them away from the other molecules, causing them to break apart and release energy in a sudden, dramatic way. And then there are the hypergolic reactions. That's when two substances ignite spontaneously upon contact, without any external spark or flame. Manganese heptoxide can do that too, especially with fuels like acetone and ethanol. It's like they were made for each other, but their relationship is short-lived and explosive. By now, you're probably getting the picture. Manganese heptoxide is not a substance to be trifled with. It's highly reactive, potentially explosive, and demands the utmost respect. If you're ever handling this compound, remember safety first. Always wear appropriate protective gear, gloves, goggles, a lab coat, the whole 9 yards. And never ever work with manganese heptoxide outside of a well-ventilated fume hood. Remember, the fumes it produces can be harmful if inhaled. Disposal is another important consideration. You can't just toss this stuff in the trash or pour it down the drain. Manganese heptoxide requires careful neutralization before disposal following strict safety protocols. So there you have it. Manganese heptoxide, a fascinating, volatile, and potentially dangerous compound. It's a reminder that chemistry is full of surprises, and while we can marvel at the power of these reactions, we must always treat them with caution and respect.